Now let's review some of the questions from question set number 2. In question set number 2, we're asked to find the resultant phasor. So now we're going to take two phasors and we're going to add them together. Question 2a gives me two phasors, one of them 45 amps at 35 degrees plus the other phasor 70 amps at 54 degrees. So what do? First, we need to plot each of these phasors onto their individual triangles. And here's triangle number 1. Has a hypotenuse of 45 amps and an angle of 35 degrees. Triangle number 2 70 amps on the hypotenuse, 54 degrees. Perfect. So now we can start to solve for the other sides. Let's start by using our sine function to find the opposite. So sine theta is equal to the opposite divided by the hypotenuse. How do we isolate for the hypotenuse or for the opposite? We just do some quick cross multiplication. The opposite is equal to the sine of 35 degrees times by the hypotenuse of 45 amps. The opposite of this triangle would be equal to 36.862. Write that down. 36.862. Okay, now that we've solved for the opposite, let's solve for the adjacent. So we'll use our cosine function. Cos is equal to the adjacent divided by the hypotenuse. Transpose that to isolate for the adjacent. The adjacent would be equal to cos 35 times by our hypotenuse of 45. The adjacent would be equal to 25.811. Write that down. 25.811. Just clean that up a little bit. 36.862. Fantastic. Same procedure for the second triangle. Start with sine. Isolate the opposite. Opposite would be equal to sine 54 divided or multiplied by 70. Opposite would be equal to 56.631. Now we got to do the adjacent. Isolate the adjacent. The adjacent would be equal to 41.145. Fantastic. So now that we've found the horizontal and vertical components of these two triangles, what is our next step? First, let's spend a minute and graph these two phasors. Phasor number 1. Sorry about the arrow on that. 45 amps. Remember, when we're drawing our phasors, if we're representing a current phasor, it has a closed arrow and it occurs at 45 amps at 35 degrees. Our other phasor is also a current phasor. Closed arrowhead, 70 amps at 54 degrees. So we now know that our resulting phasor will be longer than 70 amps and it'll be in between 54 and 35 degrees. So how do we solve for this? Let's draw our horizontal vertical table. Horizontal values, vertical values. I have horizontal values of 36.862 and 41.145. I have vertical values of 25.811 and 56.631. They give me totals. Whoops. Let's clean that up a little bit. Give me totals of 7.78.007 and 82.442. Fantastic. Our next step, take that new horizontal and vertical, so our total horizontal and our total vertical, plot that on our new triangle. So our horizontals, 78.007, our vertical, 82.442. Do some Pythagorean Theorem now. So now all we have to do is we have to solve for the hypotenuse. So we can do that by using Pythagorean Theorem. So we will go 78.007 squared plus 82.442 squared. And then we take the square root of that. Will equal 113.498. So that's my hypotenuse. 113. Oops, sorry. 0.498. Now that we know the hypotenuse, we can use some trigonometry to find the angle. So sine theta is equal to the opposite, 82.442 divided by 113.498. So sine theta will equal 0.726. How do I change that into an angle? I have to go second function sine. So theta would be equal to our angle, 46.5 degrees. 46.5 degrees. So our resulting phasor has a magnitude of 113.498, and it occurs at an angle at 46.5 degrees. And that's question 2A. Now let's go on to question 2B. Question 2B has two phasors. Phasor A is 120 volts at 145 degrees. Phasor B, or the second phasor, would be 80 volts. 80 volts at 65 degrees. Step number 1, we need to draw both of these phasors onto triangles. Phasor A, so our hypotenuse would be 120 volts. Our angle would be 145 degrees. Phasor B, would have a hypotenuse of 80 and an angle of 65. What are our steps? First, we can use the sine function to solve for the opposite. Cross multiply to isolate the opposite. The opposite would be equal to the sine of 145 times by the hypotenuse, 120. The opposite would be equal to 68.829. And then we can use our cosine function to find our adjacent. Now when we're looking at this first phasor, it occurs at 145 degrees. If I was to really quickly graph that out, 145 degrees would occur in the second quadrant. So it would tell me I'd have a positive vertical, but I would have a negative horizontal. So as I'm performing the function here, the trigonomic function, I should be expecting a negative value. Really quickly, cross multiply. So my adjacent would be equal to the cosine of 145 times by 120. Should give me a value of negative 98.298. And is that what we were expecting? Yes. Based on our graphing of our phasor over here, I was expecting a positive horizontal and a negative, I was expecting a positive vertical and a negative horizontal. 98.298. Fantastic. Now I'll just really quickly write in the values for the second triangle. After doing your trig, you should have gotten a vertical of 72.505 and a horizontal of 33.8. .809. Is that what we would have expected? Yes, because with an angle of 65 degrees, that puts me into the first quadrant, which would give me positive values on both my horizontal and my vertical. Now, let's add up our horizontals and our verticals using our horizontal vertical table. And what were our two horizontals? Negative 98.298 and 33.809. Our vertical values, 68.829 and 72.505. Total those up. You're left with negative 64.489 and 141.334. Now looking at these two values here, I have a negative horizontal. So let's quickly draw our crosshairs. So if I have a negative horizontal, I know I'll be in quadrant number 2, and I have a positive vertical. So absolutely, I should end up, if I do everything right, somewhere between 91, use the right pen, somewhere between 91 degrees and 180 degrees. All right, well, let's build our final triangle and find out. My horizontal, negative 64.489. My vertical, 141.334. Use Pythagorean Theorem to solve for that. So 141.334 squared plus negative 64.489 squared, square root. So C would be equal to 155.352, 155.352. Now we need to find the angle. So let's go ahead. Let's use our sine function. Sine theta would be equal to the opposite, 141.334 divided by our hypotenuse, 155.352. Sine theta would be equal to 0.91. So our angle, after we take the second function of the sine, our angle would be equal to 65.473. But according to our values in our horizontal vertical table, I know that I'm going to be in the second quadrant. So I know that I've rotated past 90 degrees, but I haven't reached 180. So how do I find this angle? I go 180 minus 65.473. And that should give me 114.527 degrees. So the answer for this question then would be I'd have a resulting phasor with a magnitude of 155.352, and it would occur at 114.527 degrees. Now, some of you might be wondering why I don't use 90 degrees to figure out my angle. Why don't I just add 65 to 90? Well, if we remember from our earlier lesson, the horizontal axis is referred to as our reference axis. We always reference any of our angles to the horizontal. So that's why I know I couldn't reference it from 0, because 0 plus 65 would have put me into the first quadrant. And that's not where I needed to be. So that's how I knew I had to minus 180. Okay, so that handles question 2b. Let's move on to question 2c. Question 2c is once again the addition of two phasors. Phasor number 1 is 54 amps at 165 degrees. Phasor number 2 is 18 amps at 92 degrees. Okay, I think we have the trigonometry figured out, so I'm going to just plot these really quickly and write all the values in on these triangles. 54 amps is my hypotenuse. My angle is 165. I have a horizontal of negative 52.16. And I have a positive, or a vertical of a positive 13.976. So if I graph this first phasor, I know it has an angle of 165 degrees. So here's 90, here's 180. 90 is positive, 180 is negative. I know I'm in the second quadrant because I'm at 165 degrees. So would I expect a negative horizontal? Absolutely. Would I expect a positive vertical? Absolutely. So that way now I've double checked triangle number 1 has been done correctly. Okay, triangle number 2. I've got 18 amps at 92 degrees. I have a horizontal of negative 0.628. I have a vertical of 17.989. Once again, we'll spend a quick second and we'll graph this. Here's my 90 degrees here, which is my positive. But now I've rotated past 90. I've rotated past 90 to 92 degrees. So I'm into that second quadrant again. So just to double check, would I expect a negative horizontal? Absolutely. Would I expect a positive vertical? Right on the money. So what is the next step? Next step is to add these two values together, or these two triangles together on my horizontal vertical table. So what are my horizontals? Negative 52.16 and negative 0.628. My verticals, 13.976 and 17.989. Add those up. Gives me 52.788, which is a negative value, and 31.965, which is a positive value. Once again, really quickly, let's just graph that. So if I have a negative horizontal, I know I'm going to be somewhere out towards 180. And I have a positive vertical, I know I'm heading up somewhere towards 90. So I know that my resulting phasor will once again be somewhere in that second quadrant. It'll be somewhere between (90) and 180 degrees. Perfect. So let's just put those values onto our new triangle. So I have a horizontal of negative 52.788. Have a vertical of 31.965. Use Pythagorean to find the hypotenuse of this triangle. Should give you 61.71. And the angle, we use the sine function, should give you an angle of 31.197. But because we know we're supposed to be in the second quadrant, and we know we need to be between 90 and 180, what do I need to do with this 31 degrees? I need to subtract it from 180. So 180 minus 31.197 gives me an angle of 148.803 degrees. So the answer for this question would be the resulting phasor would have a magnitude of 61.71 at an angle of 148.803 degrees. And that concludes part 2 of the phasor addition review.